The AP2 S2000, the better car, but is it the better Honda? Or better yet, has the S2000 soul been stripped out with this second iteration due to that lower red line? These are burgeoning questions that we'll answer in this video from an engineering perspective, as we conduct an automotive x-ray on this car and dive deeper into what makes this one of the greatest attainable sports cars of our time. Before we dive in, let's appreciate the iconic status this car has received in not just games, but also around the world, and also the fact that it still dominates comparisons against the brand new GR86 and ND3 Miata, which, despite a head start of 2 decades of engineering, still don't capture that visceral nature of the S2000. For this video, each section has been divided into either the engine, gearbox, dynamics, suspension, or the chassis and underbody. So without further ado, let's begin on why everyone wants an AP2 S2000, the engine. Let's preface something before we get into the F22 C1, which is the motor that the AP2 S2000 has. The F20C, which we've covered extensively in our AP1 S2000 video, was actually used for the AP2 in all other markets, except for North America and Japan from 2006 onwards. Enthusiasts call this version of the S2000 the AP1.5, as it still has the F20C, but all the other changes the AP2 gets. And with that, let's get the basics out of the way when it comes to this F22 C1 motor, which is a 2.2 litre inline-4 producing 240 horsepower or 239 horsepower in Japan at 7800 RPM and 220 Nm of torque at 6500 RPM in North America. Like the F20C, the F22C1 uses a one-piece cast aluminium alloy engine block as well as fiber reinforced metal cylinder liners, and using this material allows for lower weight, faster heat transfer, and less wear and tear over time when compared to conventional ferrous metal liners. Unlike the F20C's over square 87mm bore by 84mm stroke design, the F22C1's focus on more torque down low means it now uses a slightly under-square design by changing the stroke to 90mm. This was done through changing the crankshaft half stroke from 42mm to 45.3mm and decreasing the connecting rod lengths by 3.35mm. With these changes, you no longer get that mythical 9000 RPM redline that the AP1 has, only 8200 RPM, as you've probably seen from the onboards at the beginning of this video. This means that the AP2 S2000 has a much wider power band from 3000 RPM compared to the AP1's 6000 RPM, and this is actually prepared for track work so that the car actually stays in VTEC more often on tight technical routes. This is shown through the horsepower and torque band between 1000 to 8000 RPM being increased by 4 to 10%. With the additional 2 or 3 horsepower from the USDM F20C, the compression ratio has gone up slightly at 11.1 to 1 compared to 11.0 to 1. Using a higher compression ratio actually allows the same combustion temperature to be reached with less fuel whilst giving a longer expansion cycle, so you get more power. Just like the AP1, this engine is also placed at the back of the engine bay to put as much weight as possible to the center of the car so that the car has a low polar moment of inertia, giving the vehicle quicker and sharper rotation and turn in. With a high capacity engine, you naturally add more weight. So to ensure the weight difference isn't too much for the AP2, Honda have used lightweight forged aluminium pistons that are 9 kilos lighter than the AP1s, and Honda realized they didn't need the pistons to be as strong given the lower redline. The connecting rods are carburized and each weigh 649 grams, and the crankshaft, which are also steel forgings, are heat treated for added toughness. To add to this high revving nature, the F22C1, just like the F20C, also uses large ladder type cast aluminium stiffeners with cast iron bearing inserts, which runs the full length and width of the lower engine block. To maintain engine rigidity, a cast aluminium oil pan has been used to help dissipate heat, and cast aluminium as a material reduces NVH compared to your traditional steel stand pan. Let's talk about the dual overhead camshaft cylinder head before we get into the juiciest part of this engine that justifies why many people seek this coveted automobile. Like the engine block, it's an aluminium alloy die casting just like the AP1s, with the combustion chambers shaped into a pent roof, with 4 valves for optimum high RPM airflow. And the valve springs, they are a single element round profile type that are basically the same as the AP1s. Now, onto the juicy bit, VTEC. Just like the AP1s, it's used on both the intake and exhaust valves, repacking the maximum amount of air and fuel into the combustion chamber on each intake stroke, and then releasing the maximum amount of exhaust gases on the exhaust stroke. Each intake and exhaust valve uses 2 different cam load profiles, one for low RPMs and one for high engine RPMs. From idle to around 6,000 RPM, the 2 intake and exhaust valve cam followers at each cylinder are operated by low RPM cam lobes, and at this 6,000 RPM mark, you get this VTEC just kicked in yo feeling, where the ECU will tell a spool valve to open and send oil pressure to pins in the cam followers. Here, the pins lock the 2 intake valve followers and the 2 exhaust valve followers to a third follower, and now the car stays in VTEC until you go below 6,000 RPM. For the low speed VTEC profile on the AP2, the low speed intake duration has been decreased and exhaust duration has been increased so you get more torque. And for the high speed VTEC profile, it's been changed, with the high speed intake and exhaust duration slightly decreased for torque and top horsepower. Let's just replay that VTEC kick, shall we? Simply lovely. For the rocker arms and coaxial VTEC cam followers, which use roller element bearings, Honda have used the same powdered metal injection molding process as the AP1, not only for better high production efficiency, but also consistent quality control compared to the older casting and machining methods they had used. This change alone has reduced valve train friction by approximately 70%. Let's now dive deeper into the oiling of the F22 C1, which is essentially the same in the F20C. The 2 overhead camshafts are hollow, so that oil is supplied to the cam lobes for lubrication, and by doing this, Honda didn't need to implement a separate oil line and nozzles, and to help minimize engine length so the engine is pushed as much to the back of the engine bay as possible, the oil pump was actually placed on the side of the engine block instead of its usual location at the front of the crankshaft, and with this change, the oil pump scavenges oil more efficiently. Placing the oil pump lower than usual also helps pressurize the lubrication system more quickly during engine startup. The oil pump itself uses a smaller, high-speed rotor and suction pickup ports on both sides of the pump body, and the pump is driven by a silent chain connected to the crankshaft. With the engine placed all the way at the back of the engine bay, Honda engineers placed the entire intake system in front of the F22 C1, where the system can draw cool air directly from in front of the main forward engine compartment bulkhead. And since the system does not sit on top of the engine, the hood is lower, meaning better visibility. Now, specifics on the intake system. It consists of a large 5.5 litre expansion chamber, a low resistance conical axial flow air filter, and a main resonator. From the air filter, intake air flows in a short, direct path to 4 large section tuned intake runners, and these runners, along with the cylinder head intake ports, have been carefully angled to provide the shortest, straightest airflow path into each cylinder. From 2004 to 2005, Honda used a cable throttle body, so you get incredible throttle response and no ref hang, unlike the drive-by-wire, which was unfortunately used from 2006 onwards, so that does make the throttle feel more delayed. Let's dive deeper into the exhaust system for the AP2 S2000. It's a low restriction, high efficiency exhaust system with the exhaust manifold using large diameter stainless steel tubing, and is a 4x2x1 design that flows gas efficiently. And the design choice of using a pre-chamber and 2 main silencers that utilize a U-turn pipe arrangement further reduces back pressure, and too much back pressure is bad, as that means less power. For the CR, this U-pipe is actually removed from the muffler for a sportier exhaust note. So it's quite clear now that the F22C1 is one of the best engineered engines ever, but we need something that allows it to operate at its best at any speed. So let's now talk about the slick shifting transmission. Before we delve into the gear ratios, let's touch on the technicals when it comes to this transmission, which is mounted longitudinally, and with all 6 manual gears and reverse on 2 parallel shafts. By coupling both transmission shafts at the output end, Honda has reduced the load on the gear synchronizers by as much as 40%. Not only that, but shift loads are also reduced, making shifting easier. The transmission shift linkage is mounted on top of the transmission case so you don't get any shifter slop, and shift throws are short and direct, which can be a double-edged sword, as many owners have reported that it is easy to misshift on the 6-speed manual. The shift throws are made even shorter in the S2000 CR, with the shift knob being spherical. For the shift lever, Honda have used aluminium alloy and floats in the rubber mounting that absorbs vibration, and the race engineering shines through the S2000 manual transmission using its own lubrication pump, driven off the transmission secondary gear, and this pump ensures the gears and synchros last long. Speaking about the synchros, there are double carbon single cone design for 1st and 2nd gear, and a single carbon cone design for 3rd to 6th gear, and these all help reduce shift effort. Reverse gear meanwhile uses single cone brass synchronizers to reduce NVH. This carbon material is actually new for the AP2 S2000, and Honda have done this to reduce mechanical loss. For the clutch, Honda engineers opted to use a pull type clutch mechanism and reinforced friction materials better suited to the high RPM nature of the powertrain. Of course, when you have 240 horsepower at the rear wheels, you need a type of diff that can put the power down without wheel spinning, and Honda have done that through adding a clutchless torsion limited slip differential, which automatically transmits drive torque to the wheel and tire with the most traction. But how does the power get transmitted from the differential to the wheels? By using a set of rigid one-piece axle shafts, the powertrain now has quicker throttle response. Let's now have a brief look at these gear ratios and compare between the AP2s on the left and AP1 on the right. Whilst we can see that the gear ratios from 1st to 4th are basically the same, the secondary gear reduction has been decreased by 4% to accommodate for the torquier nature of the AP2 S2000, with the final drive remaining the same. Let's now focus on what makes this car so special around such corners: its dynamics. We already know that AP2 S2000 can go straight and hit VTEC, but how can it turn through the twisties? By steering. So let's cover that then, shall we? It's an electrically assisted rack and pinion setup like the Honda NSX, whilst loads of reviewers have remarked the steering lacks feedback, opting for an EPS rack not only saves weight as you don't need a hydraulic pump and hoses, but the issue of leaking power steering fluid is practically eliminated, something that's actually quite a common issue on the Acura RSX. The electric motor that provides the assistance is microprocessor controlled. It provides more assistance at low speeds and lesser high speeds, as the faster you go, the more your tires load up, meaning your steering naturally gets heavier anyway. However, Honda have increased the rigidity of the steering mount bushings, reprogrammed the EPS from the AP1, and changed the steering ratio to be a lot slower at 14.9 to 1 compared to the AP1's 13.6 to 1. These changes are why a lot of S2000 purists actually prefer the AP1, as it's an overall sharpened driving experience with that faster steering rack, and it's also why Honda decided to use a 13.8 to 1 steering ratio for the CR, as well as steering gearbox stiffeners to give better steering feedback. So the AP2 S2000 can go, but how can it stop? Through using 4-wheel cast iron disc brakes, which are 11.8 inches at the front and 11.1 inches at the rear. The front rotors are also vented for added cooling, while the rear discs are solid. The brake calipers are also cast iron and are highly rigid and large, with the front piston diameter being at 54mm and the rear pistons at 40mm in diameter. The pad material is a high performance fade resistance type, with the brake pad area 42 square centimeters for the front pads and 27.9 square centimeters for the rear brake pads. Whilst the rotors, calipers and pad dimensions have stayed the same from the AP1, the pads themselves have actually been upgraded from an NF71 in the AP1 to Urid 32 at the front to give better pedal feel as well as resist brake fade better. To help your brake, Honda has used the same 7.8 inch single vacuum servo assist unit from the AP1 to offer the best balance between pedal feel and assist, and the braking bias front to rear has also been optimized so that the front and rear brakes operate at maximum braking efficiency during heavy braking. In terms of the wheels, they're an open 5-spoke pattern that are 17 by 7 for the front and 17 by 8.5 for the rear and are made of lightweight aluminium alloy. Another important thing to note is the front and rear tyres being different sizes, with 215/45 R17 87W at the front and 245/40 R17 91W at the rear. The rear tyres are made even wider on the CR using 255/40 R17 94W. This is a staggered wheel and tyre setup, and in powerful rear-wheel drive setups, these setups are almost always used, as wider rear tyres help put down the power more effectively. Honda have gone an inch up on the wheels and tyres to not only increase grip and cornering ability, but also what we call snap oversteer, which we'll get onto in the next section. Let's now move on to the quads and hammies of the S2000 AP2, the suspension. All S2000s from AP1 to AP2 use a highly rigid in-wheel double wishbone suspension all round, consisting of upper and lower wishbone arms at each wheel, with coil-over spring/damper units and anti-roll bars. For the wishbone arms, they're made of ductile iron and are connected to the body through special rubber bushings, which are designed to minimize vibration without compromising suspension rigidity. Double wishbone setups compared to more traditional McPherson struts or torsion beams are great, as you get what we call camber gain, which is essentially when the suspension is compressed, the wheels slant inward a bit more. With this in mind, Honda didn't need to run huge amounts of static negative camber from the factory, only running a mild 0.5 degrees at the front and a slightly more aggressive 0.1.5 degrees at the rear on both the AP1 and AP2. Ball jointed lower arms have been used to increase roll stiffness, as well as a front stabilizer bar carried from the AP1 and a new rear stabilizer bar, which is thinner by 1.8mm to mitigate the AP1's issue of snap oversteer, which is where, when that rear suspension is loaded up, sudden weight transfer can cause the suspension to decompress and then snap the rear end sideways. Fortunately, this is an issue that the AP2 S2000 solves, with the rear toe being decreased, the roll center lowered, the front spring rates increased by 6.7%, and the rear spring rates made softer by 10%, to not only make the car more neutral, but it also gives the driver more time to correct the oversteer of the S2000. The stabilizer bars, which are connected to their respective suspension arms via ball jointed links, actually help the AP2 S2000 corner quite flat. On the other hand, the S2000 CR boasts a 38% increased front spring rate and a 70% increased rear spring rate, on top of the 2008 S2000's increased spring rates of 7% at the front and 9% at the rear. With the damping, the S2000 CRs increased by 50% at the front and 32% at the rear. To accommodate for the more aggressive suspension setup, the front stabilizer bars have increased in diameter by 5% and decreased in wall thickness by 19%, and the rear stabilizer bars have increased in diameter by 5%, with the wall thickness remaining the same. So why is the S2000 CR so stiff? This is as the S2000 CR is dubbed Club Racer, basically building it for the racetrack and making it very unfriendly on the street. So not only do you get an even sharper turn-in, but also better grip. To reduce this body roll even more, the AP2 S2000 uses monotube shock absorbers, which have been readjusted to help reduce the snap oversteer, instead of a twin tube setup. This design choice not only allows the car to corner more neutrally, but also feel stable at high speeds, however at the trade-off of a slightly stiffer ride, as you do have more gas pressure in those shocks than you do with twin tubes. Attached to the lower wishbone arms are rear dampers, which feature large remote reservoirs, leaving more space available for the folding soft top and space saver spare tyre. With that being said, let's now move on to the final but arguably crowning aspect of the AP2 S2000, the chassis and underbody. Let's start off with the weight. It's very light, weighing only 2,811 pounds or 1,275 kilos. This is made even lighter in the CR, weighing at 2,813 pounds with the hardtop on and 2,765 pounds without the hardtop. And a big thing they did to strip weight was not include a spare tyre. Instead, there's now only a tyre repair kit at the back. In terms of the styling, it isn't just form, but also function, with the hood line dropping away to a low, strong nose shaped for minimal aerodynamic drag and good forward visibility. The front bumper design has also been changed, and this uses a wider opening air intake, so the coefficient of drag has been lowered by 5%, so the aerodynamic performance has now been improved to give you more stability on a racetrack. With the CR, a front underbody spoiler and a rear wing spoiler have been used to reduce the coefficient of lift by roughly 70% with the hardtop removed and 80% with the hardtop installed. With the hardtop removed, the roll bar cowlings help direct airflow to the inner part of the rear wing spoiler to reduce lift, and installing the hardtop directs more airflow to the rear wing spoiler, giving you rear downforce. Say you're driving with the top down on a racetrack. What if you crash and your car rolls over? Well, the S2000's roll bars combined with the car's cantilevered windshield frame to help form a protective area for the driver and passengers' heads. However, we always suggest a roll bar for real track work. To help reduce noise when the top is down, Honda have installed a clear acrylic panel between the driver and passenger roll bars to act as a wind deflector. The short 6 gear means this car does hum a bit noisier than the average consumer will like, so Honda have included vibration absorbing edge mounts and suspension bushings, resonance damping chambers in the intake and exhaust systems, and soundproof materials applied to the floor tunnel and trunk to reduce as much NVH as possible. On the other hand, the S2000 CR removes these sound deadening materials to get the weight down. With the front mid-engine setup, the weight distribution is a perfect 50-50. Before we discuss the legendary chassis this car offers, watch me twist this shoebox without a lid, and now watch me do it with the lid on. See the difference? The point is, open top cars have a way floppier chassis, so with this in mind, Honda designed a monocoque body with a centralized backbone frame for the S2000. For the AP2, they took it a step further than the AP1 to make the chassis even stiffer, and increased torsional body rigidity by 10% in the front and 9% in the back. We'll touch on the changes they made which led to this increase as we go through the chassis of the AP2 S2000. Firstly, the backbone tunnel is enclosed by the floor and runs down the center of the cockpit between the driver's and passenger seats. The large side sills provide extra strength, and the diagonally braced front and rear bulkheads, which have added reinforcements for the AP2, tie the frame members together into a strong beam-like structure that resists bending and torsional forces. The cross members running under the driver's and passenger seat add extra stiffness, and reinforcements have been added here, as well as a performance rod for the AP2. Brackets have been added to the front upper A-arms to increase structural rigidity. The front and rear portions of the central frame and the side sills tie into diagonal X-braces at the rear of the cockpit and at the front cowl, and these X-members connect directly to the front and rear suspension subframes. That's why it's often called the X-bone frame. Despite the front subframe's lightweight and compactness, its lateral rigidity is quite high, with the edge and mount structure designed to reduce lateral movement in the frame when cornering. On the other side, the rear subframe is a three-dimensional structure consisting of hollow steel pipes that connect the rear side members and floor tunnel to the upper and lower arms of the rear suspension. A deep section rear cross member ties the beams together and anchors the rear of the differential. Funny enough, for the S2000 CR, you don't even get a soft top, only a removable hardtop. So Honda have included a steel rear body brace, which connects the two coil-over towers on the fender wells for added body rigidity at the rear. This brace is installed at 3 locations: the top of the fender well, the rear floor, and to the backside of each roll bar hoop. And this is where we'll end off regarding the engineering for the AP2. This car was never about the speed, it was always about the driving feel and sound. With that, let's now head into the concluding remark. Overall, what are my thoughts on the AP2 S2000? whilst it has sorted out a lot of the snap oversteer issues through adjusting suspension geometry and steering and become a better track car with the chassis enhancements and more optimal power band, we feel that the AP1's 9000 RPM redline as well as more snappy drive dynamics are closer to the identity the Honda set out this car to have. The entire point of the S2000 was to have incredibly sharp handling, so that's why they prioritized placing the engine as far back as possible, and with the AP2, we feel this ethos may have slightly been sacrificed. Thanks again for everyone for tuning in and leaving kind words and incredibly helpful advice in the comments to help improve our videos, and I'll see you in a bit.